Kia ora Year 12 and Year 11. I'm going to start going through the summer 2019 papers and doing all of the vector questions in a row. Now, I had great plans of doing all 6 parts in one video, but it's just not going to work. So as usual, it's going to be one paper and one question per video. So here's the question here. It's one of these ones that when you first see it, most of you probably think, ooh, yuck, it's some 3D picture thing, but that actually really helps us here. We've got a set of axes with the origin here. We've got 4 points. We've got A, B and C that are sitting in the XY plane, and then we've got point D up here. So it's basically a kind of pyramid thing. We're given position vectors. We've got OA, OB and OC, and then OD. We have to find the equation of the plane BCD, giving our answer in the usual form. Now that's worth a whopping 6 marks. I reckon that's actually a really, really easy question now, especially if you're confident with using the vector product. Then we have to calculate the acute angle between the plane that we found up here and OABC. So I just want to talk about how we find the equation of that plane OABC before we get into the rest of the question. Right, well by this point in the year you should know that the key to finding the equation of a plane is to find the normal vector, right? The normal vector to the plane is perpendicular to that plane. But here, this OACB is sitting in the XY, it is the XY plane, right? And the short version is that this plane has equation Z is equal to 0. Now how can I find that by thinking about a normal vector? Well, the normal vector here is this. It's the vertical axis, right? It's the Z equals some constant, because that is going to be, where's a different colour pen, that vector is perpendicular all over the XY plane in here, right? So the normal vector we can take as 0, 0, 1, just as we always do. So it's going to be Z is equal to some constant, but we know that the origin is sitting in the plane, right? So that's a very long way to say that the plane that we're going to be working with in here is really, really easy. It's got Z equals 0. And this BCD we're going to find in here. And the thing that we always use to find an angle between two things is cos of theta is equal to the dot product scaled by the magnitude of the two vectors multiplied together. So that's pretty much the whole question. So let's get going on the first part now. So if we're going to find the equation of plane BCD, we're going to have to find some other vectors. So we're going to need BC, and we're going to need CD, or we could do BD, doesn't really matter. So the first thing that we'll start with is rewriting those IJK vectors as column vectors. So BC is going to equal this. It'll be 1 minus 3, 3 minus 4, and 0. Right, so that's working with this one and this one. So that gives me negative 2, negative 1, 0. What about CD? Well, CD will be 2 minus 1, 3 minus 3, and 5 minus 0, which gives me 1, 0, and 5. Now, if you wanted to start that more slowly, you could write out OA, OB, OC, and OD. So the normal vector N we can take as this. It's BC cross CD. So how do we do that again? Well, we write down our I, J, and our K, and then we go plus, minus, plus to remember how the determinants work. Determinants are the crossover subtraction thingies. Alright, so here I'm just writing in this vector, and I'm writing in this vector, and they go in as rows. So that gives me I times, so we're knocking out this row here, and we're left with negative 1, 0, 0, 5, minus J times negative 2, 1, 0, and 5, plus K, negative 2, negative 1, 1, and 0. Now, if you're looking at those determinants that I've written out properly here, don't freak out. In the next step, I'm about to show you how we do that with our brackets again, and it's fine for you to jump straight to that, right? So it's I times this, take away this, so it's I times negative 5 minus J times -10, right, this, take away this, plus K times 0 minus negative 1. So that gives me my normal vector, negative 5i plus 10j plus k. So we're just about finished. So the plane pi is negative 5x plus 10y plus z is equal to c. So we have to pick a point on the plane, and I'm going to pick point B, which is 3, 4, 0. So that tells me negative 15 plus 40 plus 0 is equal to c. C is equal to 25. So we can write the plane equation as negative 5x plus 10y plus z is equal to 25. I'm sure you'd get 4 marks for that, but it's really ugly, so let's change it over to this. 5x minus 10y minus z is equal to negative 25. So there you go. That's the first part of the question done. Now you don't have to use the vector product. If you want to use it using another method, I suggest you go look at the mark schedule, because I'm not going to go all the way through it doing simultaneous equations, but you can do. Right, and that method's also done really well and really slowly in the textbook. Let's move on to finding the angle between those two planes. Right, well, I've already talked about OABC. The equation is z equals 0. And we can use this. Cos of theta is equal to 0, 0, 1, the normal vector of the first, times 5, negative 10, negative 1. So the dot product of those scaled by the magnitudes of those vectors. So we get a very not nice number here, which is the square root of 126. So negative 1 over root 126. So as we saw, I think in the school exam paper that we did, we had the same thing where we're getting a negative value for cosine, and that's a big flashing light that what we're finding here is not the acute angle, right? Because we know from our cosine curve that we're somewhere down here. So when we chuck that into our calculator, we get this, and that gives us a value for theta of 95.1. So the acute angle is 180 minus that, which is 84.9. Now please don't hang up the video yet, because I want to go back and show you why that answer makes total sense. All right, that's to 3SF. So just look right back at the picture you were given at the start and try to visualize it. So if you think about this back wall of the pyramid here, it's on a very slight lean if it's drawn anything like to scale, which actually it kind of looks like it is. So this angle in here is the one that we're looking for, right? The acute angle between those two planes. So the 95.1 that we found to start with was the angle going out here on the other side. So in here, this, I'm trying to wave my hands while I record, it's not really working, but this is tipped slightly inwards, and so our answer of 85 point whatever it was, 84.9, makes complete sense. Alright, so that's the first of those questions. I'm going to do question paper 32 straight away now, so that we can just blast through a little bit of vector revision. Thanks for watching, and let me know if the sound and everything's okay, because I've been playing around with the mic a bit.